Hi there, and welcome to this lesson. In this lesson, we'll be doing basic algebra, okay? And under basic algebra, we'll be learning factorization of algebraic expressions. So, factorization. In the last lesson, we did expansion. In this lesson, we're doing factorization. I tell you, there is a relationship. There is a relationship between the two, expansion and factorization. And we'll find out exactly what that relationship is shortly. So yeah, as the lesson progresses, if you have any issues at all, anything comes up as unclear, please feel free to get in touch. Okay, we would be more than happy to help. And now let's jump right into the lesson. So factorization of algebraic expression. Now what exactly is factorization? Now to understand factorization, we need to know what factors are. Now factorization, the word comes from factors. So what exactly are factors? Now factors are smaller terms that can divide a given algebraic term. Okay, so just like it's similarly in arithmetic, when you have what are the factors of 12, the factors of 12 are the numbers that can divide 12. So the factors of 12 are 2, 3, 4, 6. Now similarly in algebra, the factors of an algebraic term, for example 2xy, are the smaller terms that can divide 2xy, i.e. 2x and y, because 2xy can be divided by 2, it can be divided by x, can be divided by y. So what then is factorization? Now, factorization is a process of simplifying an algebraic expression using the common factors of its constituent terms. Okay, so for example, I have this algebraic expression here. I have 7m squared minus 35m, and what we're going to do is we're going to go ahead and factorize this. Now, to factorize this, we're going to draw out the constituent terms. So we have two terms. We have 7m squared as the first term, first individual unit in the expression, and the other term is 35m. So 7m squared, and I'm going to draw out the factors of 7m squared. What are the factors of 7m squared? We have 7 times m times m. Okay, so these are the smaller terms that would divide 7m squared. It will be divided by 7 and be divided by m, so we just break it down: 7 times m times m. Okay, now what about 35m? Okay, 35m, can you do that? Let's give it a go. So you have 35m would be divided by 5 times 7 times m. Okay, so we will break it down to 5 times 7 times m. Now what we're going to do now is we're going to find the common factors. Okay, so we're going to just look on there and find the factors that are common. And basically I think we have 7 and we have m. Okay, so 7 and m, and I don't think we have any other common factors. So our common factor here is 7 times m, 7m. Okay, so we found our common factor. Now what exactly are we going to use 7m to do? So we have our expression 7m squared minus 35m. Okay, and we're going to break this down using our common factor. Our common factor is 7m. Okay, the common factor of 7m squared and 35m is 7m. So write out 7m, and then we introduce this bracket. Okay, and we look 7m squared divided by 7m is m. Okay, and then minus 35m divided by 7m is minus 5, and go ahead and close the bracket, and that is it. That is factorization. Basically, if you look closely, you'd find that expansion, there is a relationship, like I said, between expansion and factorization. And when you factorize something, you make it simpler, you break it down. And when you expand something, you make it bigger. Basically, you expand it, you open it up. So factorization is the direct opposite of expansion. Okay, remember in the last lesson we're expanding algebraic expressions, and this time we're making them bigger then, and right now we're factorizing, we're making them smaller. So yeah, and that is pretty much what we'll be doing in this lesson. And let's go ahead and factorize some algebraic expressions. So example 1. And example 1 says factorize the algebraic expression 2a plus 6. So first thing we want to do is we want to find our common factor. Now we have two terms in this expression. The first term is 2a and the second term is 6. Now can you find the common factor, something that would divide 2a and would also divide 6? The common factor is 2. Okay, so we have a common factor, and then now that we have a common factor, we can go ahead and factorize. We have 2a plus 6, and if we divide that by 2, 2a divided by 2 is a, and 6 divided by 2 is 3. So we factorize and we have 2a plus 3. Simple, straightforward. Let's move on. So example 2. And example 2 says factorize the algebraic expression ax squared plus 2ax minus a squared x. This is looking a bit more complicated, but nothing that we can't handle. Let's go ahead and do that. Okay, so now the first thing we need to do is we need to find a common factor. We have ax squared, 2ax, and minus a squared x. I tell you the common factor there is ax, i.e. a term that can divide all the terms there, because we can divide ax squared by ax, we can divide 2ax by ax, and we can divide a squared x by ax. So that is our common factor. The next thing we want to do is we want to divide through by ax, and when we do that we end up with ax multiplying x plus 2 minus a. Very simple, very straightforward. That's pretty much it. There really isn't much to it. Let's do another one. Example 3. And example 3 says factorize the algebraic expression 3 multiplying a plus b plus x multiplying a plus b. Now this looks very interesting. Okay, we have 3 multiplying a plus b plus x multiplying a plus b. What is the common factor here? Can you look closely and tell me? The common factor is a plus b. Okay, if you look, we have two terms. Let's say we have two terms there, and we have 3a plus b. Let's call that a term, okay, an individual unit, and we have x a plus b, okay, another term. And the one thing that's common between the two of them is a plus b. All right, and basically if you looking to factorize this, you can actually factorize using a plus b, and what you have is you have factorizing using a plus b, you have a plus b, okay, and then the first term divided by a plus b is 3, okay, and then the second term divided by a plus b is x. So you have a plus b, 3 plus x. Very simple, very straightforward. Let's move on. So example 4, and example 4 says factorize the algebraic expression xy plus 2y plus 3x plus 6. This is looking interesting now. So we have xy plus 2y plus 3x plus 6. Merely looking at this, you can tell that there isn't one common factor. There isn't one common factor that would divide all four terms there. Okay, and basically, how do we approach this? All right, now I'm going to introduce you to something called factorization by grouping. Okay, now if you look at the terms there, basically you have xy, 2y, 3x, and 6. I can group these terms. Okay, and when I group these terms, basically I have xy and 2y. Xy and 2y would have a common factor. Okay, if you look at that, I think the common factor there will be y, and 3x and 6 will have a common factor. The common factor there would be 3. So I'll group the terms, okay, because there isn't a single factor that would divide all four terms. Okay, but then if I group them in twos, each group would have a common factor. Now once I've done that, the next thing I'm going to do is obviously factorize each of them. Okay, so I have xy plus 2y. I'm going to factorize that with y. I have x plus y multiplying x plus 2, and then I factorize the second one with 3. I have 3 multiplying x plus 2. Now if you look closely, you'd find something very interesting. You'd find that we actually have another common factor, i.e. x plus 2, and we can go ahead and factorize using x plus 2, and what we have is x plus 2 multiplying y plus 3. Simple. Our final example, example 5, and example 5 says factorize the algebraic expression 2x squared plus ay minus ax squared minus 2y. Okay, so this is another case where we have four terms in the expression and there isn't one single common factor. So how do we go about factorizing this? I think we can attempt grouping, okay, but then we can't group right away because the terms aren't really arranged in a very nice clean manner like we had in the previous example. But what we can do is we can find the terms that have common factors and bring them together. Okay, so in a way collect like terms. All right, and once we've done that, basically we bring 2x squared and ax squared together when we bring ay and minus 2y together, and once we've done that we can then go ahead and group them. Okay, it makes a lot more sense now. And then once we've done that, we can factorize each group. Okay, so we have factorizing the first group, we have x squared multiplying 2 minus a. All right, and factorizing the second group, we have y multiplying 2 minus a. And oh no, we have minus y. Okay, because if we factorize using y, we'd actually have a minus 2. All right, well, if we factorize using minus y, we have 2 minus a. I think I need to touch on this. Okay, let's make this clear. So if you look at what we have here, you could tell we're probably working towards factorizing using just like we did in the last example, x plus 2, x plus 2, and we factorize using x plus 2. Okay, and now we have 2 minus a in the first group. Okay, and if we factorize using y, we would end up with a minus 2. But if you factorize using minus y, you'd end up with 2 minus a. And considering we're actually looking to get equal expressions in both brackets, I think it'd make more sense to factorize using minus y instead of y. Okay, so it's just something you should take note of. It happens not too often, but it happens sometimes. Okay, sometimes you might have an expression like this and you want to factorize and you find that the two terms in the bracket are just very similar, but basically they're not arranged properly. I don't know how to make that clear. And basically, as opposed to factorizing with y, you factorize with minus y, and now it makes a lot more sense to go ahead and say 2a x squared minus y. And yeah, that would bring us to the end of this lesson. It's been a very short lesson, and yeah, bye for now.